welcome to our channel. This is Science Lectures 256. Thanks for being with us. Consider subscribing and comment in the comment section and like our videos. So today we are going to look at gram staining, and it's a procedure for identifying bacteria. So we are going to dive into what gram staining is and what it is all about. So before we start gram staining, we need to have an overview of gram positive. We have bacteria that are gram positive and bacteria that are gram negative. So this is very key in gram staining. We need to know what is the basic difference between gram positive and gram negatives in their peptidoglycan layer. Peptidoglycan and layer. We know that their cell wall is a peptidoglycan layer. Their cell walls are peptidoglycan layer. So they differ. For gram positives, they have what we call a thick peptidoglycan layer. Thick peptidoglycan layer for gram positives, and gram negatives have a thin peptidoglycan layer. So, in other words, if I'm to do a demonstration, the gram positive, if this is a gram positive, and that is the peptidoglycan, it is thick. Then gram negatives, it will be a thin peptidoglycan layer. So that is very key when we are going to do our gram staining. However, before we do the staining, we have what we call the materials we need. What are some of the materials we need before we do staining? So we need materials like crystal violet. We need crystal violet. Then we also need things like iodine. Iodine, you can call it Lugol's iodine. Lugol's iodine. We need ethanol of a high concentration. Ethanol, that is 95% ethanol. Then we also need acetone, 5%. Acetone, which is 5% acetone. Then we as well need, of course, we need water. We need water. Then we can have a stain, other stains like saffronin, or we can have carbofuscin as a stain. These ones will work as the secondary stains. Carbofuscin is another stain. Saffronin or carbofuscin. First of all, before we go deeper, you need to know that crystal violet is purple in color. It's purple in color, or blue. We can call it blue, purple or dark blue. Then saffronin and carbofuscin, they are red in color. Then the iodine we'll use will work as a mordant. We'll see what a mordant means. Iodine will work as a mordant. Then the ethanol will work as a decolorizer. So ethanol will be used for decolorizing, as a decolorizer. And then the water will be used for washing in our procedure. So let's start the procedure of gram staining, and we see how the procedure is carried out. So the first thing we'll do, we first culture our bacteria. We culture the bacteria we want to stain on a plate. Let's say this is our plate. We culture the bacteria. So this is the cultured bacteria. It has colonies on the petri dish. So we'll get a drop of water, another petri dish or slide with a drop of water, water drop. Then we add a colony using a rod, a sterilized rod. So using a sterilized rod, we get a colony of bacteria, the cultured one, we put on a drop of water. So this is our water drop. Then when we put on a drop of water, we spread the colony till turbid, till we get a turbid solution. Till turbid. So you spread the colonies. After spreading the colony, we air dry. You air dry and heat fix. So you apply some heat to fix the bacteria onto the slide or the dish. So after air drying and heat fixing, we flood we flood the slide, flood the slide, we flood your slide with crystal violet, with crystal violet. So you flood the slide with crystal violet. So you will wait for around 1 minute after flooding your slide with crystal violet. Then after you flood this slide with crystal violet, you add, remember we said crystal violet is purple. So we assume that two cell walls will pick up this purple color, so that you will have them all colored purple when you add the primary stain, which is crystal violet. Then after flooding the slide with crystal violet, you add iodine, or what we call Lugos iodine, or Lugos iodine. Lugos iodine. This works as a mordant. This will be working as a mordant in that it will help to fix the crystal violet in position. So it will form a reaction. It will have a chemical reaction between it and crystal violet. So it will have a reaction with crystal violet, that Lugos iodine, or the iodine. So it is forming that reaction. They are in conjunction with one another. So that is iodine being used as a mordant. Then after adding iodine, we can wash. We wash the slide. Of course, the washing helps in removing the excess iodine. So you wash with water to remove the excess iodine. Remember, we gave the water as one of the raw materials for our experiment. So washing the slide. After washing this slide, we then add a decolorizer. So you add ethanol. Of course, this is after now 1 minute. That 1 minute after flooding, you add ethanol, which is 95% ethanol, and acetone, which is 5% acetone. So after ethanol and acetone, ethanol is a decolorizer. So ethanol will do the decolorizing role, will decolorize these membranes. Now it is decolorizing to remove the crystal violet. That is its role. So it's a decolorizer removing the crystal violet. Then after doing the decolorization role by the ethanol, we'll come in now and add the final the final stain, and that is safranin. Safranin. So we add safranin. When we add safranin, we say safranin is red in color. So you can either decide to add safranin or you can add carbofuscin. Of course, they are both of the same color. Or you add carbofuscin. Safranin or carbofuscin. Finally, if we have gram-positive bacteria present, gram-positive, they will have the purple color of the crystal violet. They will retain the purple color. Then if we have the gram-negative bacteria, for them they will get the red color. So that is the staining technique. But in summary, we say we shall need to get the colony of bacteria. Then we add to another sterilized plate, of course using a sterilized load. So we say the first thing we flood is crystal violet, which we say is purple in color. Then after flooding with crystal violet, we can later flood with iodine, which is mordant, which is our mordant in this case. After flooding with iodine, we can do the washing. We wash to remove the extra iodine. Then after removing this extra iodine and washing, we can now add the decolorizer, that is ethanol, preferably 95% ethanol, and acetone, preferably 5% acetone. Then after adding this decolorizer, we assume that it is decolorizing the crystal violet from either the gram-positive peptidoglycan or the gram-negative peptidoglycan. But however, we say gram-positive is thick and gram-negative is thin. So that means when the decolorizer is removing this crystal violet, it will remove all the crystal violet from the gram-negative bacteria. And it will leave some crystal violet, or most of the crystal violet, in the gram-positive bacteria cell wall. So after adding ethanol and acetone, finally, we can now add the safranin. Safranin, which we say is red in color. So this safranin, which is red in color, will now enter the membrane, which is gram-positive negative, because it has lost all its crystal violet. So that is why for gram-positive bacteria, you will see finally a red color after staining, but the gram-positives, you remain with the purple color even after staining. So this is the gram staining technique, where you differentiate between gram-positive bacteria and gram-negative bacteria. So you just assume that if we had like a bacteria like Streptococcus, or Staphylococcus, let's say we had Staphylococcus aureus. We know Staphylococcus aureus is a gram-positive. Then let's imagine we also had another bacteria like Edwardsiella tada, but this one is somehow hard for us. Okay, if we had like Pseudomonas aeruginosa, which is gram-negative. For Staph aureus, which is gram-positive, we would see the final results having a purple color. Then for the gram-negative, which is Pseudomonas aeruginosa, we would see the final results giving us a red color after staining. So that is it with the gram staining technique. Stay blessed.